Good evening, everyone. So here today we are going to be looking at freefall. So freefall simply involves a body that is falling or thrown upwards under the influence of gravity. So under this one, we are going to be ignoring air resistance. So when they tell you to say that a body is in freefall or just the word dropped, it simply means to say its initial velocity is equal to 0. So if it is in freefall and the initial velocity is equal to 0 meters per second, or if they just tell you it is dropped, it means to say the initial velocity is 0 meters per second, provided that they haven't given you any further instructions. So we are going to be looking at questions that are going to be involving dropping some things. Then in the next video, we are going to be looking at if a body is projected up. Let's say we have this problem. It says that a body freely falling under the action of gravity passes 2 points 10 meters apart, vertically in 0.2 seconds. So what we are going to have is that firstly we have 2 points. Let's call this one as our point A. This one, let's call it our point B. Then if you look at our point A, so it passes 2 points. We can name those 2 points as our A and B. They are telling us that 2 points which are 10 meters apart. So we can do this and say this distance is 10 meters apart. Then we are told to say from what height above the higher point did it start to fall. So the higher point, let's have something like this. We can call this highest point to be our point X. We don't know how far it fell. Now if we are told that it is freely falling, it means to say the initial at X. So the initial at X is equal to 0 meters per second squared. Now we do not know what is the, so what we are going to do is, in order for us to find our velocity, we are going to, or rather to find the height, we are going to use some certain equations. So under freefall, we are going to be using 3 equations, which are our v squared should be equal to u squared plus our 2as. The other one is our s should be equal to ut plus our half at squared. Our third equation is v should be equal to u plus our at. So we are going to be using this under freefall. So we can be able to use any of these 3 equations. The equation that we will use will be determined by how much information we have. Now if you look at this, we are looking at from point A to point B. They have given us that the time taken for this is 0.2 seconds. So now if you look at the equation that can be able to help us, we have our v squared should be equal to u squared plus our 2as. We can be able to use this equation. Now the pressure is that we do not know what our final velocity is in respect from point X to point A. So from here to here, we do not know what our final velocity is. Then the other thing is we don't have also the displacement, which is our s there. So we cannot go direct. So what are we going to do? So what we are simply going to do is we are going to find what is the initial velocity at point A. So if you know what your initial velocity at point A is, let's say the initial velocity at the point A is 20 meters per second. It means to say this same 20 meters per second will be your final velocity if you consider your journey from where it was dropped to point A. So the same initial velocity, if you consider from point A to B, from point A to B, you will find your initial velocity, let's say 20. The same initial velocity becomes your final velocity if you are looking at the object dropped from point X to point A. So with that, we are going to first find our initial velocity provided with everything that we have. So let me just wrap this a bit. So let's find our initial velocity from point A to point B. So using the equation which has got the displacement s, it has got the time, since we have been provided that it will take 0.2 seconds, we can be able to say our s should be equal to ut plus half AT squared, like that. So our S should be equal to, we are going to say that our displacement, we have already been given that it is 10 meters from point A to B. It is 10 meters. Our initial velocity, which is equal to, we don't know, so we are going to say UT. Then we have our half. Then we have our acceleration due to gravity. Since it's going down, it shall take the positive value, which is our positive 9.8. Then we have our time squared. So our time is 0.2 squared, like that. So we can be able to say that we have our 10 meters should be equal to, we have our U, then time here is 0.2, like that. Then we have half times 9.8 will give us 4.9, like that. So we have just removed that to create more space. So our 0.2 squared will give us 0.2 squared will give us a 0.04. So we are going to put 0.04 there. Then we have our 10 should be equal to 0.2 by U. It will give us 0.2 U. Then our 4.9 times 0.04 will give us a value of plus our 0.196, like that. So taking this value the other side, we are going to have 10 minus 0.196 should be equal to 0.2U. So we are going to have minus our 10. This will give us a value of a 9.804, which should be equal to 0.2U. So we are going to divide over our 0.2 over our 0.2. Our U value will be equal to 49.02, like that. So this is our velocity at that point. So let's now look at our diagram again. So looking at our diagram, we have found the initial velocity from point A to B is found to be, initial should be equal to 49.02, like that, meters per second. Now if this is, so knowing that this is our value 49.02 at A, so the same initial velocity, if you consider your movement from point A to point B, will become your final velocity if you consider from point X to point A. So therefore you can be able to now calculate the height by using the three equations that we had for kinematics, where, so looking at these equations, we have the v squared is equal to u squared plus our 2as, or our s is equal to ut plus half at squared. So now the equation that we will pick is the one that is having an s. We do not know the time it will take for it to move from point A to point B, so we can just be able to use this equation. If you use this equation, you don't know the time of which you won't go anywhere. So we are going to say v squared should be equal to our u squared plus our 2as. So our v squared, our final velocity, if you consider the journey from point X to A, it is 49.02. So you will be able to say 49.02. We square this should be equal to our initial. If initial is at X, it means to say where it is dropped, the initial, it will be equal to 0 meters per second. We square this plus our 2. Our gravity, which is our acceleration in that case, will be a 9.8. Then we have the s, which is the height. So we can be able to square our value. 49.02 squared will give us a value of 2402.9604, which should be equal to our 2 times, so we can just have, we have a 0 there, plus 2 times 9.8 will give us a 19.6 s, like that. So we have our 2402.9604 should be equal to 19.6 s. We divide this over 19.6 over 19.6. So our s value will be equal to 2000 divide by our 19.6 will give us a value of our 122.6 0, 0. So as you can see, this is our distance from the point X to point A. So from here up to here, it's giving us a distance of 122.6. Now we were told that how far did it fall from the drop off point to the highest point, which is our A. So the answer is 122. If we were asked from the drop off point to point B, we were going to add the 122 plus the 10 that is here. But since they just want the distance it fell from the top to the highest point, which is our point A, it will be a 122 meters like that. This other one is saying that a boy is dropped into the lake from a diving board 4.9 meters above the water. It hits the water with a velocity v and then sinks to the bottom with a constant velocity v. It reaches the bottom of the lake 5 seconds after it is dropped. Find the depth of the lake and the average velocity of the ball. So how are you supposed to find this? So this problem shall be answered similar to what we had. So let's say this is our diving board from the top here. Then we have the lake. Let's say we have our lake, which is looking like this. So let's say this is our lake. We shall just put it a different color. So this is our water. Then from here up to here, we have a distance of 4.9 meters. So it is dropped from this point. Then we are told that it takes 5 seconds. So that means to say it takes 5 seconds according to what we have said, to say it reaches the bottom of the lake 5 seconds after it has been dropped. So we are told, so this is what we have. So as it is dropped, it gains speed. Now, immediately it hits the water, we are told that it maintains the speed at which it hits the water. So if this is our V there, it will be able to go like that. It continues to move like that until it hits the bottom. So it has got the common velocity like that. So what we are going to do is we are going to split this problem into two. So we know to say it takes 5 seconds for it to move from this point up to the bottom down there. So it takes 5 seconds. Now since the velocity when it was under free fall, the velocity was 0. So it gained velocity when it hit the water, and we are told that the velocity it gained when it hit the water is the same it maintains up to the depth there. So what we can do is we can find the time it will take for it to move from this point to this point. So finding the time, we can be able to say, so the equation that we are going to use is knowing that here we do not have the final velocity, we don't have the time, so we can't use this equation direct. But here we have the initial, since it's under free fall, it's 0. So we have the initial velocity there. We have the displacement, which is from here, just the distance from here up to here, it's 4.9. So we are going to use our 4.9. We have the acceleration due to gravity. So using this equation, we can be able to find our final velocity at the point where it hits the water. So we can be able to say our v squared should be equal to our u squared should be equal our u squared plus our 2as, like that. So we are going to have our v squared, which should be equal to our initial is 0, then our 0 meters per second, we square this value, we have plus our 2. Since it's falling down, it means to say our gravity will be positive, so we are going to say 9.8. Then we have our displacement. Our displacement, according to this, from here up to here, it is equal to 4.9. So we are going to put our 4.9 there. So we have something like this. So our v squared should be equal to, so if we multiply 2, so this 0 we can just forget about it. 2 times 9.8 times 4.9, it will give us a 96.04 like that. So from here we find the square root, our v should be equal to 9.8. So this is our velocity. So now if you know the velocity at which it strikes the water there, you can be able to calculate the time using this equation. By knowing the time it will take here, we can use, let's say if it gives us 2 seconds, we can use our 2 seconds. We subtract the total time, which is our 5, which would give us, if here it's 2, then the time it will take for the boat to sink, it will be a 3 seconds. So by knowing the time it will take, we can calculate the distance. So let's find the time it will take using this equation. So we are going to have our v should be equal to u plus our at, like that. So our final velocity is now known to say at that point when it strikes the water, it will be a 9.8 meters per second, should be equal to, under free fall, or if it is just dropped, the velocity will be 0 meters per second. Then we have plus our at, our acceleration a is 9.8 times our t. So 0 plus 9.8 is just 9.8. So we have 9.8 should be equal to 9.8 t. We divide 9.8, we are going to have our time should be equal to 9.8 divided by 9.8 is equal to 1 second. So we have found that the time it will take for it to move from the higher point to the surface of the water is equal to our 1 second. So what we are going to do is that 1 second, then to find the depth, that means to say from here to the depth is how more like deep the lake is. So if it takes 1 second here, it means to say since it takes 5 seconds, what it will take for it to move from this point to this point, from this point to the bottom, it will take 4 seconds. Since from the top to the bottom it takes 5 seconds. So using this one, we can now be able to say our s should be equal to ut plus half our at squared. Since we have the time, we can be able to use this equation to find the depth. Now we are told that the velocity it struck on the water is the same velocity it maintained until it dropped to the surface. Therefore, if the speed is constant, acceleration is equal to 0. If speed is constant, acceleration is equal to 0. So we are going to have s is equal to ut plus our half. Our acceleration is 0 times time squared. So this, it's more like it's nullified. So we are going to have our s should be equal to our ut, like that. So with this, we can be able to calculate the depth. The depth will be our s. So our s is equal to what speed did it hit the water with, since it was maintained. That will be our initial. So our initial will be at this point where it hits the water like that. Then it will ascend down until it reaches the bottom. So we have our u. Our u is equal to our 9.8, which it hit the water with. Then we have times our time, which is equal to 4 seconds. It takes 4 seconds for it to go to the bottom. So if we multiply 4 times our 9.8, we are going to have a value of our 39.2 meters, like that. So this is our displacement, or rather the depth. So we can just call it the depth. Let's look at our last question. So for this question, this is one way of being stupid and also getting an F in your semester. So the question says that, if you are the one who is trying to do this, it says that you are on the roof of a physics building 46 meters above the ground as illustrated in the figure below. Your physics professor, who is 1.8 meters tall, is walking alongside the building at a constant speed of 1.2. If you wish to drop the egg on the professor's head, so you want to drop the egg on the professor's head, Then you're asked to say, where should the professor be when you release the egg? Assume that the egg is in free fall. So this is, let's say this is the way it is. So we have the egg, let's say the egg is here. So what we want to do is, so this is our situation. It will be dropped until it hits the professor at that point. Now, the thing is that, firstly, what you need to account for is you need to know what time it will take for the egg to drop from the building to the professor's head. Now we are interested in the professor's head, but as you can see, this is from the building, from the top of the building to the ground. Now, if you look at the ground, from the ground to there, it's 46, but the egg does not have to hit the ground, it just has to hit the professor's head. So therefore, the distance which the egg will be able to travel will be from this point, then we are going to move until the professor's head, like that. So due to that, we are not going to use our displacement 46, but we are going to subtract. So we are going to say our 46 minus our height of the professor, so that we can find what is the distance that the egg will travel. We will subtract the height of the professor, which is our 1.8 meters. So if we subtract that, we are going to get our 44.2, like that. So this is the distance the egg will move. So what we are going to do is, we are first going to find what time it will take for the egg to drop from here up to the professor's head. By finding the time, let's say if it gives us 4 seconds, this same time is the same time that the professor has to move forward. If the egg takes 4 seconds, the professor will also have to move in 4 seconds forward, like that. Now remember, under free fall, it's like you are just here, you drop the egg like that, very close to the building. So therefore, you will see what time it will take to hit the professor's head. Then that same time is the time that the professor shall move to move forward. So we are going to say, if his speed is constant there, so we are going to say that, so among these equations, it's either we can find the speed at which it will be able to strike there, but we can just go direct by finding the time. So the time, the equation that can be used to find our time, we don't know the final velocity, so we are going to use this one. Since we just want the time, we have the displacement, which is the distance the egg will have to travel. So using this equation, our S should be equal to ut plus our half at squared. We are going to have our S, it will travel the 44.2 meters, which should be equal to the initial velocity. It is dropped, meaning to say the initial velocity will be 0 times our t there. Then we are going to have our half. Our A is equal to our gravity. Since it is dropped, it will assume the positive value, 9.8. Then we have our t squared, like that. So we are going to have our 44.2 should be equal to half times 9.8 will give us a 4.9. Half times 9.8. Then we have our t squared, like that. So dividing our 4.9, dividing our 4.9, we are going to get our value of, if we divide this and this, we are getting a 9.02, like that. So this should be equal to, we have a t squared. We find the square root of this value. We are getting a value of 3 point, yeah, so basically 3 seconds, which should be equal to t. So the time it takes is 3 seconds. So now, remember what I said, the professor is moving forward like that. Now the thing is that if the professor is moving forward like that, we need a point at which the egg will land. Now remember, the egg must be very close to the must be very close to the building so that it falls like that. Now if it takes 3 seconds, the professor will also have to move in 3 seconds. So what we are going to do is, let's find, we were told where should he be, meaning to say at which distance. So we are going to say that our using our we have everything, we have the time, we have that, so we can use our s should be equal to ut plus half at squared. So if you look at our question, it is saying that is walking alongside the building at constant speed. If the speed is constant, it means to say acceleration is equal to 0. So what we are going to do is, we are going to say our s should be equal to our initial velocity of the professor. We are given that it's 1.20, so we are going to say 1.2. Then the time he will walk, it is 3 seconds, like that. So 1.2 times 3 will give us a value of 1.2 times 3 will give us a value of 3.6 meters. So the professor is capable of moving 3.6 meters in the time which is our 3 seconds. So in 3 seconds he is able to move 3.6. Now what does this mean? So the egg, remember, it is dropped very near to the building. So what you can say is that he has to be 3.6 meters away from the building. Why away from the building? Because if it's let's say from here to here, if it's 3.6 meters away, he can be able to move 3.6 meters in front because the egg is very close to the building. That's our free fall problem. Thank you very much for watching. Hope you would like, subscribe and share for more. See you in the next tutorial. So we forgot to finish our part B. So for part B, to find our average velocity, which was for this question for a ball that is dropped. So the average velocity can be given as, should be equal to the total displacement. You can write it in full over the total time. So if you remember, so we have 4.9, that is from here up to here. Then the depth is 39.2 meters. So therefore, to find our average velocity, so our average velocity shall be equal to the total displacement. So you just add 4.9 plus 39.2, so 4.9 meters plus our 39.2 there. So we are going to get over our total time. Our total time is equal to 5 seconds. We were told that from here up to here it will take 5 seconds. So over the total time, this will give us a value. Adding that will give us a value of 44.1 on top over our 5 seconds, which will give us a value of, if we divide 5 here, it will give us a value of 8.82 meters per second. So this is how we get our average velocity, like that. So if that's our average velocity. Thank you very much for watching. Hope you would like, subscribe and share for more.